So welcome guys. So now we are treating another method using solving a quadratic equation. Completing the square method. It's another method. So it's very simple, it's very easy. So provided that you are given a question, a quadratic equation, actually quadratic equation where quadratic equation it's uh it's a equation where the value where x is an unknown actually, and the values of a b c, they are not equal to 0, so they are actually no numbers. So in this case I'm using a, b and c because I'm trying to derive a formula, actually using complex square method, that we can use in solving a quadratic equation, which is known as formula method. Well, when I get there I'm going to explain better. So now I'm going to show you a series of steps in which you can use to complete the squares of a quadratic equation and to get the answers for the values of x, which is the unknown. So the step one is to move the constant to the equal sign. When a number or an element crosses the equal sign, it changes the sign. So I'm going to be having ax squared plus bx is equals to minus c. So this constant crosses this equal sign and it changes to minus 1 plus. So the step 2 is to divide all through by the coefficient of x squared. The coefficient of x squared in this scenario is this value, the number at the side, or the value at the side of x squared, which is a. So I'm dividing all through by, it could be any number actually, any number at the side of x squared. So I'm going to be having ax squared divided by a. I'm dividing all through in the equation, is affecting the c. So now if I simplify this, a cancel a, it's going to be x squared plus b over ax is equals to minus c over a. So now we're not done. Now the step 3 is you take, to take something, you take the coefficient of b, of x rather. Take coefficient of x, which is b over a. Now the number at the side, or the value at the side of x is b over a. You take it and you multiply it by half, then you square it. So what I'm saying is, whatever is at the back of x, you take it, then you square it. So it's going to become b over 2a squared if you simplify it. Okay, and then we're going to add it, this thing we're going to add it to both the left and the right hand side of the equation. So the equation, which is x squared plus b over ax is equals to minus c over a, we're going to add this value. Why are we adding to both sides? Is to create balance, because if I'm adding b over 2a all squared, this thing I've imported here where I multiplied the coefficient of x by half and a squared, if I just add it here alone, our equation is not going to be balanced, because I just imported something here which originally is not there. So I need to add it to the other side. So even if I'm collecting like terms, and if it comes here, it becomes minus and 0, then it's out. Okay, because never part of our equation. So don't forget. And the next step, which is step 4, this step is very technical, please pay attention, is, there's an x square, there's a square here, right? There's a square, there's a square. Since there's a square here, I pick one together with the sign, I join them together, and I square it, minus c over a plus b over 2a all squared. What I've done here now, it's not magic actually. Look, if you expand this thing, you're going to get whatever is here. So I just kind of pull a trick to factorize this thing to get this thing. It's like a simple trick in mathematics to factorize this long number. So I'm going to expand this thing to prove to you that what I've done here is the same thing as this thing. This thing we're having, this expression we're having, is the same thing as this thing. So if you are given a long expression and you just pick this number and together with the sign and you square. So if I expand this thing now, just to show you, also prove to you whatever I have here is equals to this thing. If I expand it, x plus b over 2a, x plus b over 2a, then x times x is x squared, x times b over 2a is xb over 2a, plus xb over 2a, which is b over 2a times x, plus b over 2a all squared. So if I'm adding them up, xb over 2 plus xb over 2, this is going to be 2xb over 2a plus b over 2a all squared. This is going to be x squared, 2 cancel 2. This is going to be plus b over a x plus b over 2a all squared. So if you look at this thing and this thing, they are the same thing. So I'm actually correct in factorizing this thing to this thing. Just to prove to you what I've done. It's not magic. Okay, so now I'm going to continue for where I'm stopped here. So now xb over 2a all squared is equals to minus c over a plus b over 2a all squared. So the next step, which is step 5, is to take the LCM of this our right hand side. Before we take the LCM, let's expand this thing. This same thing as minus c over a plus b squared over 2a all squared, which same thing as minus c over a plus b squared. 2a all squared means this squares for both 2 and a, which is 2a times 2a, which is 4a squared. So this is 4a squared. Okay, so if I want to find the LCM of a times 4a squared is just multiply the denominators. A times 4a squared, which is 4a cubed. So I can say 4a cubed divided by a, this is going to be minus 4a squared c plus b squared a. Then a is common, I can factorize it out, minus 4ac plus b over 4a cubed. Then I can use this a to cancel out one of the a's here for it to remain a squared. So this is going to be minus 4ac plus b over 4a squared. So from the LCM multiply the denominator to get 4a cubed. Then this LCM divided by a is going to remain 4a squared. It's going to remain 4a squared, and I used to multiply minus c, there's minus 4a squared c. Then this divided by this is a times this in b squared a. So, and now I divided it, I factorized what's common here, which is a is here, it's here, factorize it out, and then I divided. So I got this after simplifying this. So now don't forget x plus b over 2a squared is equals to minus 4ac plus b. Oh, this is b squared, sorry, b squared over 4a squared. So the next thing to do is, well, remember we're trying to find the value of x, which is the unknown. So it's to square both sides, actually. And now this square roots cancel square, because square root of a number, let's say y, is same thing as y half, and if there was square here, it's going to multiply the square here, so same thing as just y alone. So it's just going to remain this value here. It's just an illustration. So I'm going to write x plus b over 2, and because I'm square rooting this, towards both sides as an equal sign here, there should be plus minus here. Okay, so plus minus square root minus 4ac plus b squared over 4a squared, and this square root for both this and this, but this number can be simplified. This square root 4 is a perfect square root of 4, give us 2. Square root of a square should give us a, so we can simplify it. So this can be minus 4ac plus b square over square root of 4a square. This is going to be b over 2 is plus minus minus 4ac plus b square. Square root of 4a square is 2a. So now the next thing is to move this plus. If it's crossing equal sign, it's going to change to minus. Minus b over 2a plus minus square root of minus 4ac plus b square over 2a. Now this plus minus, I can find the LCM here. So I'm just going, the LCM is just going to be these two equations are the same. 2 is common, so this is going to be minus b plus minus square root of minus 4ac plus b square. So wow, voila. So this is how to find the unknown value for x. This a, b, and c are actually known values that when you substitute you can get the unknown values. So this series of method I've used there is what we use in solving continuous square method. And this equation here is known as the formula equation in solving quadratic equation. So thanks.